Welcome back to Jedi Lessons Week 5 of energy conversion of energy. For this lesson, we are going to be talking about a 42 kilogram girl who is bouncing on a trampoline. So let's get our imaginary trampoline here, put some legs on it. Got some legs for our trampoline. She is bouncing on it. So she's up top. We got some hair. And she weighs 42 kilograms. Bouncing on a trampoline. During a certain interval after leaving the surface of the trampoline, her kinetic energy decreases from 170 joules, or decreases to 170 joules from 420 joules. How high does she rise during this interval, neglecting air resistance? So, she's jumping up and down. As her kinetic energy decreases, so as she's going up, she's at 170 joules. But as she comes back down and puts all of that force back into the trampoline, she is pushing 420 joules of energy into the trampoline to launch herself into the air. So, with that being said, with our diagram, with what we have read within our question, we are going to talk about the variables and the different things that we are using. So the first one, the mass, how much she weighs. She is 42 kilograms. We are also talking about her kinetic energy. We're going to be working with the kinetic energy of her initial, so her I. And then we're going to be using the kinetic energy of her final, which is F. We already have those two numbers. And that is 170 joules in her initial. And then in her final, 420 joules. We also are going to be working with the net change in kinetic energy. So this little triangle pyramid is working with the net change just to differentiate it all of her kinetic energy. We're going to figure that out by subtracting the final through the initial and then getting our the net change, the difference between the two. And that'll also be in joules. We're also going to be working with gravity. Gravity, again, is acceleration. It's the Earth's acceleration that we're using, so 9.80 meters per second squared. Height is the displacement that she is experiencing from putting so much force into the trampoline and flying up. And then we also have the change in her potential energy. So there's a lot of things to keep track of, a lot of things to work with, but we are going to be plugging that in now. So what we are going to do is we are going to get our kinetic energy of the initial minus the kinetic energy of the final, which equals mass times gravity times height. Now we have to we have to isolate height because that is what we're ultimately trying to get at. And by doing that, we have to divide both sides by her mass and the gravity. So the mass of the initial is 420 joules minus the final. As she's going up, that's when she reaches her peak before she starts falling down again. It's 170 joules over how much she weighs, 42 kilograms, times the gravity, which is 9.80 meters per second squared. So we are going to do our calculation now, which is 420 minus 170, which equals 250, over 42 times 9.80, which equals 411.6. Dividing that together would be 250 divided by 411.6, which equals 0.607. Again, just like the last video, we have 3 sig figs here. Actually, we technically have 2 sig figs there. We have 2 sig figs here, and we have 4 here. And since we're working with division, we're going to reduce it down to 2 sig figs since we're working with the lower one. So this 0.607 is actually going to equal 0.61. And then since we're working with the height, because h, if we pull that over, then it'll be kinetic energy of the initial minus the kinetic energy of the final over, so h will equal mass times gravity. And since we're figuring out the height is in meters. That is how high she went by putting that much force in with how much she weighs. Thank you.